Recently, I was working on creating tutorials about GraphRAM. For that, I had chosen Neo4j as the database. Now, Neo4j database uses Cypher language to, parse the graph, traverse it, find friends of friends in the nodes, and traverse the edges. One thing I came to know is if you know SQL really well, if you have been working with SQL, learning Cypher is very, very easy. But Cypher has some more capabilities that it could surpass SQL in some of the scenarios that we will see in the video itself. So let's jump to the video. Let's see how, if you are working with SQL on a daily basis, how to convert simple queries into Cypher queries, parse the graph, the nodes, the edges, and then finally we will see what SQL can't do or it's very hard to do in SQL, which is very easy to do in Cypher. Okay, so the main core mental shift between SQL and Cypher thinking is very simple. In SQL, you know which rows match and how do you join them. So there are some inbuilt IDs that SQL creates. But in Cypher, which graph pattern matches and how do I walk it? How do I traverse it? That is the question that you ask while you are writing the query. So this is the core mental difference between SQL and Cypher when you are working with them. So let's jump to our example schema, like what examples I have been picking, and I've created a SQL database and a graph database with same data. And then we'll see how SQL queries are getting written and how Cypher queries are getting written to retrieve the same data that we are going to work on. So we have a relational schema where we have users, we have products, we have the orders, we have order items, we have reviews, and we have follows. It's very simple schema to understand. Now in graph, what are we building? So this is some syntax from Cypher. So let's try to read it. So it has a user which could place a order. Now user and order, these are type of nodes. Okay. And the relationship between them is defined by this particular method, and that is placed. So a user will place a order. Similarly, order node will contain nodes which are of label product, and the relationship between them would be contains. Similarly, a user can review a product. This particular relationship has two things: rating and text. It could have some properties. Each node can have some properties. Okay, like user can have email, name, and all different types of property. Product also could have price listed on product name and other things. And finally, user node is linked to another user node by a follow relationship. Okay. So this same type of data will load into SQL and will load into Cypher, and then we'll compare how queries are going to work there. So Cypher syntax have explained you how nodes are represented, how relationship are represented, and how to combine them to find a path. So this is a path like from user to order. These are two nodes, and the edge is the relationship which is placed. Okay. So let's start with a simple SQL query, that is select. We need to get first 10 users that we have. So it select ID name from users limit 10. Similarly in Cypher, we use match all the nodes with label user. And then if the nodes are matching with the label user, we need to return some parameters of that nodes. It would contain ID, it would contain name. Those are predefined. When you are creating nodes, it is predefined there. So this returns you all the users. So let's try to run this into terminal. I'll give you a brief like how these are working. So this is a Cypher Postgres database that I've created. If I just write select star from users, so if you'll see there is a name and the city and ID. So there is Alice, Bob, Charlie, and Dave. Similarly, Neo4j is also running in Docker, and this is the inbuilt UI that Neo4j provides us. So here the database information is there. All the nodes, that different node labels we have created are there. All the relationships that we can create is also visible here. And these are the property keys. So if I just click on user, it will run match user return n limit 25. So all users it has returned. So this is Charlie, Bob, Alice, Dave. Now see the representation between them. Here it is a relational database. So in a format of table, we are getting a list of users. But here these are just nodes. There is no interconnection between them, no edges between them, but these are just nodes. Let's say if I want to see the product, so this is the product: coffee grinder, desk mat, laptop, and mechanical calculator. So if I just go here and I type for select star from products, oh my bad, from products. So it will give you laptop, mechanical keyboard, coffee grinder, and desk mat, and their prices also. So if I, let's say, click on this particular node, it also has an ID, it has a price, it has a name, and the database ID is also there. So these all price, name, IDs, all of these things you can define when you are creating these nodes. Let's move ahead and see the where clause. So if you want to do a where clause in SQL, it's very simple. Select name from users where city is equal to Seattle. This is the where clause that we put in SQL. Here what we do, there are two kind of where clause you can put. So first is match user, so it will first match all the nodes which has a user label, and then finally you can do a where clause very similar to Seattle. So let's just copy this and let's go to Neo4j and I'll just update this query. So here if you'll see, it has returned me Alice and Charlie. So if I go to Charlie, it is Seattle, and also Alice, it is also Seattle. For Bob, it's New York, and for Dave, it's Austin. Another way of doing filter on node properties is if I just pass city colon Seattle, and if I just comment this will also give me Alice and Charlie. So in both ways, you could apply where clause. Okay. Now let's jump to string matching like query. So like is the operator in SQL, and you know the percent sign also where to start and where this regex pattern, how this works. Very similar to this is in Cypher where this is the clause and contains is the keyword. So for like we have contains. Okay. Then let's come to joins. Joins is something where you will understand how easy Cypher is going to be, how traversing the graph is easy and it's really fast. So in SQL, there is a user table and there is an order table and they're connected with the foreign key. But in Cypher, these are just nodes with different labels and they have to be connected using a relationship. So it is placed here. Okay. So let's say if I just copy this, what it is going to give me is it is going to give me the name, ID, and date. Now, similar way, if we want to run into Neo4j, the Cypher query, what we'll do is we'll do match. Okay, then we'll need to first define the node. So it will be in simple brackets. It will be user, and then hyphen sign. Then in square bracket, we'll define the relationship. So place the relationship, then an arrow and to which node label that we are referring to, that is, let's say order. So orders, so return, let's say u dot id, u dot id, u dot name, and o dot date. So it has given me username, user IDs, and the date of order that we have placed. In the backend, how it's working, user node is connected to a order node with placed relationship. This is a very powerful way of extracting the data and storing the data as well. Now let's jump to many joins. In many joins, we do multiple joins. Okay, and similarly here also we could do order and product contain. So just the similar pattern is there, and you'll find all the orders with the product. So a particular product can be present in multiple orders, but you just have to do like this. Okay, just the same query it remains. So we can see that in many joins, when converted to Cypher, we are already saving a lot of lines of code. Then we'll move to multi-hop join change. So let's say we are from users, starting from users, we are going to orders, then order items, and then product. So we have joined all of them. So let's say if I just run this query in SQL, it'll give me name and laptop, like the user and what product it has ordered. But now let's say if you want to get this data in Cypher, what we'll do is we'll do multi-hopping between the nodes. So if we'll start from a user node, we'll find the relationship placed to the orders, and then orders contains the product. All the nodes would be linked with the relationship contains. So it will find all of the things. So let's try to run this query in Cypher. If I just run this, it'll give me all the usernames and all the product names that they have ordered. Okay. Then seventh part is filtering on the join metadata. So let's say we are involved with 3 to 4 tables and there is a where clause. That means for a particular node in between, we are filtering on metadata, which is very similar to this thing. Okay. So the match query remains same. The return statement also remains same. Only a where statement is being added is that is very similar to the SQL. Now let's work on left join. Left join is very simple in SQL. We just do left join and table, and then we define on the keys where we are going to do join. In Cypher, it is optional match. This left join is replaced with optional match. So you have to pick a kind of node, then you have to pick another kind of node with this particular on clause. Okay. So it will find all the user nodes, and this is the variable u. So this is related to order with relationship placed. If this is matched, then it will return u and order ID. So let's just try to run this query in Cypher. I'll just run this. So it has returned me all the users and the order ID. And the power of left join is it will not delete the data from the left table. So that's why Dave has no order ID. So it is returning you null. Now group by and aggregation. So group by is a keyword in SQL that we use. In Cypher, we use a return statement. It would be return u.city and count u as user count. So if I just go and paste this in Cypher block, it has group by based on users. Like from Seattle, there were 2 users as we have seen previously, and all these counts are there. Now let's come to having. Having is used to put the filter on the fields once the group by clause has run. Okay. So if you'll see this particular query, we are getting u.name and count of order IDs that user has placed after grouping by on username. And after that, we are putting a having clause on the total number of orders. So if we translate this into Cypher, it will be first finding all the matches. So all the relationships with placed. After that, we'll use the with clause. So this group by and having is converted into with clause. So we can define u and count of orders as order count. And then finally, once this is done, we can directly use this particular variable to filter out. And then finally, we use a return statement. So self joins is a classical example. In our example, what we have seen is a user can follow a user. So let's say you want to find what particular users follow a particular user. For that, you will need to join user table with another user table. So it joins follows on follower ID with user ID, and then again joins the user on this U2 ID with the follower ID to find like which user one is followed by user two. And it becomes really simple when you are dealing with Cypher. It's just another relationship. That's all. Let's try to execute both of them to understand how easy is it in Cypher. So let's start with SQL. Alice is followed by Bob, Bob is followed by Alice, Charlie is followed by Dave, and Dave is followed by Alice. If I just go to, like, let's not run this query. If I just go here and if I just select follows, it will give me a graph. So Charlie follows Dave, Dave follows Alice, and Alice follows Bob, and Bob follows back to Alice. So it has written the same query that we have tried to execute here. That's all. Then we come to exist. Exist is very similar to what we use in SQL, where exist is the keyword, and here also where exist is the keyword. And let's say if there is a subquery in Cypher, also we could pass subquery like this. Then array aggregation is another thing that we need to look upon. Array aggregator is kind of a function that we can use in SQL, and we can pass all the strings or maybe numbers there, and if you do a group by, it will collect all the elements and it will convert into a list. So what this SQL query does is it is starting from user, it is joining on product and reviews, and it is telling that a user has reviewed how many products. products. So if I just copy this and run this in this SQL shell, it'll give me that Alice has reviewed mechanical keyboard, Bob coffee grinder, and Dave laptop. Okay. So if I talk about Cypher, we just need to find a relationship between user and product. Okay. With the relationship reviews, and it will return you all the things. And array aggregator now becomes collect p dot name. A very, very, very simple, very easy to do it. Now let's have some look about where Cypher destroys SQL. Destroy SQL as in where SQL is like very complicated, the queries become too long to understand also. Where Cypher excels. Here are few examples. First is variable length traversal. So the question is, who are friends of friends of friends of Alice? That means who is a follower of follower of follower of Alice, up to three hops. If we are going to think this in SQL, there could be a lot of multiple joins, and we have to create CTEs and then hard coded union logics that we need to put in. But in Cypher, it is very easy. It is just a number. So we'll start with the match. First, we'll fetch all the nodes of user with metadata filter containing name equal to Alice. And then we'll find all the relationship follows to another nodes which is labeled as user. But now you could just define how many nodes you want to traverse when you are traversing it. It is just a number, so it could be anything. Okay, and then finally you will just use a distinct thing because we have seen the example. Alice follows Bob, and for Bob follows back to Alice, so Alice would be in this list, and we don't want it. So just do a distinct. That's all. Okay. So this is like friends of friends of friends, multiple hopping. It's where Cypher excels. Second is path extraction. So let's say I give you two things like this is the product, this is the user. Are they connected to each other or not? Now that's a very valid problem that people solve today when we are dealing with graphs. And here it is just a very simple query. Match path equal to, we'll start with user, we'll filter it for Alice, and we'll, instead of just follow or just putting some number, we'll do a star. It'll connect all the dots in the graph and see whether Alice and Dave are connected or not. Okay. So this is how it will return the path. Let's try to run this and see what it returns. So I'll just paste it and I'll run it. So yeah, Alice and Dave are not connected. But if I do Bob, then I think we should give Alice and Bob follows. This is the relationship that exist between these two users. That's all about this particular tutorial. I was just working on learning Cypher, so I just thought whether putting a relationship between SQL and Cypher can it make understanding the Cypher or starting with Cypher easy or not. It has done for me. I think it has helped you also. If it does, please let me know in the comment section. Thank you.